Okay, so we have another circuit where we want to find the minimum clock time. And on the problem before, we said that our minimum clock time is going to be your propagation delay, your max propagation delay, plus your setup time, plus the time through all the gates for the longest path. So the longest path from flip-flop input to flip-flop input. So our minimum amount of time here is going to be, so we have our maximum propagation delay is 1 nanosecond. Plus our setup time is 0.6 nanoseconds. And now let's see if we can find the longest path. So the longest path so the longest path looks like it is probably this one. Okay, and we have the time for a gate, TGK, is 1 plus 0.1 K, where K is the number of inputs. So on this path, I have 1, 2, 3 2 input gates. Nope, and this last one is also a 2 input gate, so I have 4 2 input gates. So one 2 input gate is 1 plus 0.1 times 2, or 1.2, but I have 4 of them, so that's 4.8. So that's the time to go through all my gates. So plus 4.8 nanoseconds. So let's see, 1 plus 0.6 is 1.6, plus 4.8 is 14, carry the 1, 6.4 nanoseconds. I didn't write down the answer. Let's see. I think that's right. Yep, 6.4 nanoseconds. Okay, and it's also asking for the frequency. So the frequency would be 1 over 6.4 nanoseconds. So that would be 1 over 6.4 times 10 to the negative 9. And I'll open up my calculator. And while we're doing that, it also says to draw a timing diagram to illustrate. So first of all, so Q0, Q1, Q2, Q3, all of those take the same amount of time. So that's that. Okay, so this is Q0 through Q3. And this amount of time right here, that would be our propagation delay. Okay, so then we have to go through some gates. So to get to D0, you would go through one gate. So that would add an extra amount of time here. And that, excuse me, that amount of time is this 1.2 that we have right there. And then D1 goes through 2 gates. So we'll still have that propagation delay right there. And then we'll have the time for one gate, and then we'll have the time for another gate. So that's an additional 1.2. So D2 goes through 3 gates. So that additional amount of time right there is another 1.2 nanoseconds. And then D4 goes through 4 gates. So we'll have yet another 1.2 nanoseconds. And then we are required to have our setup time, so it has to stay stable for a certain amount of time. And that is our setup time, which we are told is 0.6. So then we have 0.6 right here. So that's this time right here. And so our total amount of time, this was our maximum propagation delay, which I think we said was 1 nanosecond. Was it? Yeah. And then if you add all those together, you get 6.4 nanoseconds. Okay, so now I was going to get the frequency, which I wanted to use my calculator for. And so it was 1 over the clock time, and the clock time was 6.4 nanoseconds. So 1 divided by 6.4 times 10 to the negative 9. And so that's 156.25 megahertz. Or 156.25 megahertz.